Okay, now I want to create another directory with the name of st, and what I want to do is to also copy the string.c like before to this st folder, and I want to move the string compare.h, and also I want to move the library of string lib.c, and now I change the directory to st, type ls. What I want to do is to go inside the string lib.c and create a lot of other functions. So let me just press Ctrl C to all of the first function, and I just press Ctrl U a couple of times to create 7 or 8 more different functions. Now what I want to do is to go at the beginning of the page. So this is the mgh compare function, and I want to name other functions. This would be mgh compare to. I just want to create other functions which we don't use inside our main file. So this would be mgh compare tree to see if, for example, the difference of the static library and shared library, when the size of the library is much bigger, and we don't need to we want to see how it goes when we combine a big library, or the difference between a static library and shared library. Let me actually just change all of these functions. mgh compare 4, I just want to change the names which we won't use inside our main file. Compare 6, 7, 8, 9, any other name that we want, that we won't use. mgh compare 10, and that's it. So we have created 9 more different functions which we won't use inside our main file. Now what I want to do is to also enter the string compare.h and declare or actually we don't need to declare them because we are not using or any of them in the string.c file. Now what I want to do is to create a static file using the information in the previous lecture that you saw how we could create a static library. So I say gcc -c stringlib.c to create a object file, and then use the ar command. The name of the static library should start with lib, so lib string.a, then a string compare dot string lib.o, hit enter. We have created another library, a static library called lib string.a. You know how all of these things work. I'm just repeating them. So gcc -c string.c, and at last we link them together by saying -o, the name of our executable. I want it to be a string, then string.o, and at last lib string -a, and I hit enter. And when I execute my string file, well, we get the output, but I want to look at the size of this executable. If we hit enter, you see the size has been increased to 13 kilobytes, even though we haven't used any one of the functions, just the static library, because it has been big, and because we have combined it with our real file, the size has been increased to 13 kilobytes. Now I want to do the same thing inside our shared library. So what I want to do is to again, or actually let me open another file, go back a directory, or another tab, sorry. What I want to do is to create another directory. Let me name it sh2, and again copy the string.c to sh2 directory, then string compare.h, and well, what you are going to do is to also move the file, this string lib.c, which has been we have created well other function inside it. I want to copy this string lib.c inside the sh2 directory. So right now if I type ls, you see, actually let me just go to the sh2 directory ls, and you see we have a string.c, a string compare.h, and a string lib.c. If I go to the string lib.c to make sure that this is actually the bigger file with a lot of other functions which we are not using. Now I want to repeat all the steps that we did for creating a shared library in the previous lecture for these new files in here to see the difference. So first of all, I say gcc-f pic for creating the position independence, so you know all of these things. String lib.c, then I say gcc-shared-o, the name should start with lib, string.so, and we pass it the object file which we created in the previous step .o, then gcc-c string.c to compile our main file, and then gcc-o, the name of our executable, string.o, and lib string.so, and finally I want to copy the new lib string.so, but first I want to remove the last lib string file inside the directory of user lib. So it was lib string, sorry, all the files inside this directory would start with lib, so lib str string.so. I want to first remove this and then copy the new lib string.so inside the user lib directory, and finally I say ld-config, hit enter and execute the string. As you see, we have all of this output in here. What I want to say ls, the real reason that we have done all of these things is to check the size, -la and then a string. Now if you notice, the size of our string is equal to 8592, while in the first shared library we had the same size again. So it doesn't matter how big the shared library is or how many functions have been defined inside the shared library, as long as we are only using the 3 functions in there, the size is the same. And actually, if we even use other functions, the size would be increased by a very small amount, while in the static file you see the size has been increased by a large amount. If you just compare this with the first static library, that our first executable string was using a static library, the size was 8656, while now the size is about this size, more than 13 kilobytes. So you see, I just wanted to show you something so that you would understand that when to use static libraries and when to use the shared libraries. I mean, right now, by just looking at the sizes, you could understand that if we have a big file and we are not using a lot of different functionalities, and well, we may want it to be portable, or we don't have any problem with it being portable, we use shared libraries because the size of the executable doesn't get bigger. On the other hand, sometimes like the first scenario which you saw, the shared library size, the final executable, because of the shared library and a static library, the difference in the size wasn't that much different. In that case, well, it would be better to use a static library. Why? Because in the static library you only need your executable, in this case the string executable, while in the shared library we should always carry our library, as you saw in the shared library example how we copied it inside a user lib directory. So I wanted to, the real reason for this lecture was for you to understand it, to feel it, instead of just explaining that these are the benefits of the shared library and these are the benefits for the static library.